All right, everybody. Hi there, and welcome for part two of our data visualization stream. My name is Stephen. I'm here to lead the workshop today. And yeah, who is out there in the chat? Anybody want to give me a little shout out to let me know that you're there and watching? I know that we've had some really exciting streams lately. We had um, some part one of this workshop, but we also had some scribbling that we did with Aziman and solving algorithms with Alberto and Jocelyn. So yeah, lots of really good activity happening um, in Global Hack Week. Does anybody have a favorite stream that they've seen so far? Yeah, let us know if you do. Yesterday we made some temperature plots, which was really fun to see some of the people's work on that. And so today we're going to do a little bit of some different things, some more visualizations, but with different libraries. And why don't we get started? So let me put up those slides for us for today. All right, so for today, we're going to talk a little bit about some of these concepts. Oh, sorry, this is actually the wrong slide. This is from last time, what we talked about. So last time we did discuss some of the types of basic plots and when to use them. And we discussed some customization techniques and also the importance of labeling and clarity. So let me go ahead and paste a check-in link in the chat. Make sure that you are checked in for today, because it lets us know who is interested in what kinds of content, and it also gives you points for swag and other benefits from Global Hack Week. So definitely make sure you take advantage of that. And today's objectives are exploring some advanced plotting techniques using Seaborn. So Seaborn is one of the other Python libraries that is used for data visualization, and it's actually based on Matplotlib, but it's a little bit more polished, I would say, and there's some functions and some features that you can do with Seaborn that are not available from Matplotlib. Excuse me there. And so we're going to talk a little bit about Seaborn today. And we're going to take the chance to visualize distributions. So we're going to learn a little bit about that. And then we're going to move on and talk about some relationships, how you could visualize relationships between variables. And then we will talk about categorical data visualization, which we did a little bit of in the Matplotlib, stream last time. But we're going to expand upon that by covering a little bit of Seaborn. And we'll customize some Seaborn plots together, and then we'll do some hands-on exercises where we dive in deep to some of these and load some things. We're gonna just basically go crazy. I'll show you a website called Kaggle where we can download some neat data, and everyone will get the chance to download something that they're interested in, and we'll visualize them. So all right, let's go ahead and get started. So I'm going to just skip the recap and go straight into Seaborn. So we're going to learn about Seaborn, and it's essentially a data visualization library that is based on Matplotlib, and it provides a high-level interface for drawing attractive statistical graphics. So if you're trying to explain something to a client or parse some user data that you have, you could use Seaborn. And the way to install it is by using a simple pip command, pip install Seaborn, and then you can import it. And typically you'll see Seaborn imported using the key phrase SNS. And so you would just type SNS dot and then whatever method you want. So if you ever see that in somebody else's code, it's probably Seaborn. And I'm going to load in a built-in data set. Seaborn comes with these. We can actually, if you want to use it later on in the hands-on exercise, that's totally okay if you want to use a preloaded one. So I'm going to load a built-in data set in our coding Scratchpad. So let me actually share my coding Scratchpad. You can see a little bit of what we did last time. We did some pie charts in Matplotlib. Pie charts are one of my favorites because you actually just type plt.py. Isn't that funny? And so, yeah, we talked a little bit about pie charts last time. Let me clear out some of this code. Yeah, we'll just clear out that code from last time. And I'm going to double check that Seaborn is installed because I don't want to necessarily have to run the command again to install it. I'm going to use conda list to do that, and we'll just check to see is Seaborn there. Yes, it is. All right, that's great to see. And so that means we can run this statement here, import Seaborn as SNS. Okay. And so now we should be able to do that load data set thing we were talking about before. And so you use SNS dot load data set, and this is kind of cool. I'm curious what's Titanic. Oh, maybe these were all of the people, the passengers of the Titanic. That's so interesting. Wow, okay, maybe that would be a good one to try for your project at the end. But today we're going to start with tips, which is basically a data set of tips that were received by restaurant staff in the normal course of business. So they've told what is the bill, what was the tip that the customer left, what was the sex, was that person a smoker, what day of the year was it or week was it, and what time. Was it a dinner service? Was it a breakfast service? And the size of the party. So that's our data set that we're going to look at right now. And I'm just going to save this data set to be equal to the variable tips. It's going to, and I'll just say .head, which gives us that first few rows of the data set. And yeah, this is some kind of data frame, actually. We could call this a pandas data frame because it does have the columns, the index, and the data filled. Okay, and we're going to talk about visualizing some of this data. So now I'll move on to visualizing distributions. So one really common thing to do is a histogram, or also a KDE plot. And KDE stands for kernel density estimate, or estimation, I guess. So basically what that means is that you're going to estimate the distribution, the curve of the distribution based on some sample of the data. And so why don't we try this dist plot command? We're going to go into our code, and we'll actually type the following. So we'll type in a new cell, sns.distplot, which is that distribution plot, and we'll type total bill as the column we want to plot. So that's going to give us a way to visualize that total bill. So I'm going to add some title, just like we did in the last workshop. And I guess I'll add some show command. We're going to need to import matplotlib too, because we didn't do that yet. Because these commands are actually matplotlib commands. And this is a really important distinction because we need to make sure that that we know that we can actually use matplotlib commands on Seaborn, because Seaborn is sort of built off of matplotlib as a dependency. So when we run this, we get a great distribution. I like this because it shows the histogram, which we talked about histograms before. And the curve is a continuous curve that is the kernel density estimate. I got a comment from Chairman Truth. Just joining today, which IDE is being used? That's a great question. So I tend to like to use Visual Studio Code, and there's a link for you so you can grab it. It is probably the most common one used by software engineers and data scientists. And what I like about it is you can actually get the Jupyter notebooks in here. So there's an extension you can install called Jupyter. And we talked a little bit about Jupyter in our last workshop. But when you install that, it will let you have notebooks. So it's really, really nice. And yeah, you'll need to install some of these like Seaborn and Matplotlib, but that'll be really good. Have some other folks joining in. No Tramish, hi there. You didn't miss too much. We're just getting started with Seaborn. In fact, let me put some of this code in a code share, because that will help anybody who is behind the 8-ball on these, if you're joining late or anything like that. I'm going to put this in a code share. It's pretty simple so far what we've done. We just loaded in this data set of tips that we have. Let me paste that into the chat so that you all can see it. And if you go to that link, it will let you download the tips, the code, excuse me. And actually, I'll just give 1 minute, just so that you all can catch up if you're joining a little bit late. Get your IDE downloaded and your codes running. Oh, sorry, my mic was muted there. Hopefully that lets you catch up a little bit. But let's go back to this distribution that we found. It's the distribution of the total bill. And I actually want to show you a few things about this distribution. So for one, let's actually compute the mean bill. So we're going to compute some statistics in a new code cell. We're going to say the mean bill, and we'll just use this function .mean on that total bill column. And the mean bill is what we could also call the expected value of the bill. So if you had to bet on what would be the bill, this would be a good guess. Now, one thing I'll say about this is that could be a little bit misleading because, of course, if you look at this mean bill, it's 1979. It's unlikely that there's any bill in the whole entire data set that is exactly $19.79. What it means instead is that if you were to take 100 customers from this restaurant and add up all of their bills and then divide by 100, you would get this number. I would be willing to bet that you would get this number. And the more customers that you add up to that total, the closer you'll get to the mean bill. And that is actually something called the central limit theorem. So this is a really important concept. And let me actually share my screen to show you it, because not everybody knows about this. So hopefully you can see a little bit here, the central limit theorem. If you look at this here, it's a really good illustration. So you see that the population distribution, this is what we're plotting here with our Seaborn command, dist plot. That population distribution could look like really anything, but it will have some mean. And in our case, the mean is $19.78. I almost said 75, but no, it's 78 cents. And if we take samples from that population, so let's say we grabbed 10 of the orders or grabbed even 100 of the orders, and we took the average, it would sort of lie in this really tight range. And so we could use that estimate to reliably predict the statistics of the mean. And oh, thank you, No Tramish. 79, actually. Yes, I guess. Yeah, I forgot about the 1 penny there. So thank you. Very important to be accurate on these things. So that really is the central limit theorem, and it's what it's what the mean is telling us about. And this sigma here, so that's this top thing here, this circle, that is going to be the variance, actually the standard deviation of the distribution, and that's going to tell us how tightly compact things are. So let's actually compute that as well, because we already computed the mean, so why not keep going? And so if we compute the mean, the standard deviation of the bill, that's actually going to be .std. Okay, so oops, there's my code. Sorry about that, everybody. Just going to make it as big as possible for all of you. So yeah, that's going to be the standard deviation of the bill. And so why don't we print some of these out? So we'll see that the expected value of the bill might be $19.79, but there's quite a bit of deviation. And so the deviation we compute is 8.9. And that means that when you look at this 19 here, it's likely, in fact, that you could get something within, let's say, one of this standard deviation. So you could get 19 plus 9, which would be 28 or 29. That's right around here. And it's also likely that you could get something less, which would be down here, let's say at around 10. Okay, so why don't we actually plot the mean here? I'm going to plot it by using plt.axvline, which stands for the vertical line. And I'm going to plot that mean in red. So let's just plot it. And there's the mean. And you might be asking, hey, why is it that the mean is a little bit to the right of the peak? Because if you look at the peak of this distribution, it's actually a lot closer to, it's a little bit lower of a bill than the mean. Well, that's because there are a few bills that were really expensive on the right. So, of course, your bill can't be any less than 0, right? So, there is that really hard cutoff on the left, meaning that most of the values will be kind of concentrated towards there. But of course, some customers might come with their whole family, or they might be rich and they buy some really expensive meals, and they're going to bump up this mean value. So now I'm going to show you about another statistic called the median, which will get us a lot closer to that peak. And let's look at that now. So I'm gonna compute a new statistic here, and I'm gonna say median bill. And I use the dot median for that function, and median is going to tell us the point at which half the bills are bigger and half the bills are smaller. So when we run this, get a median bill of 17.795. So I guess that'd be $17.80. And then we will put that in. And I'm going to actually use a new color here. Let's use green. And we can use this line style dashed. Remember, we can use really anything we want from the original matplotlib library in our Seaborn code, which is so nice because it lets us combine them. And you can see the median is a little bit closer to this peak here. So it's indicating that 50% of the values are below and 50% are higher. So if you want a metric that's a little bit less sensitive to these really high bills, and you want to just see, you know, half the bills, what are they, right? And what are the other half? It could be the median could be really good for that. Okay, so now let's keep chugging along. We have a few more of these examples to do. We did this distribution of the total bill, but now let's compute the total distribution of tips. And we're gonna include both the histogram and kernel density estimate. And so KDE equals true is how you turn on that kernel density estimate. It's actually on by default, but this is just showing you, you know, how you would make sure that that's turned on. And then bins tells us how many bins we want for our histogram. So the more you have for bins, the finer the little bars will be that appear for your histogram. So let's check this out. Let's take a look. And so we can do a new plot. And, oh, sorry, that's a little bit further along, a little bit further along there. So we can do dist plot just like we did before. And we'll do the tip column. And remember, we can do true or false. Actually, why not we just do false, because that will just show you what the difference is between the two. And then we'll add a bin. We'll add a distribution of tips. And why don't we add in some of our central measures of central tendency. So we did some mean and median here. Okay, so we actually I added a little bit of pizzazz to this solution, but It's not going to show the kernel density estimate this time, but it will show 20 bins of a histogram and also the central limits here. So if we run this, you can see that we have a really strong central value of around a little bit less than $3 per tip. And yeah, we'll just have a lot of tips at the top that might be from really generous customers, but most of the tips will be around 3. And you'll notice that if we divide, let's divide the mean value for the tip. So we have tip.mean. So there's the mean value for the tip. If we divide that by the total bill mean, that'll give us the tip percentage. And if we calculate that, we get about 15%. And 15% is a pretty common tip in the United States, where I'm from. Actually, we would probably leave a little bit more on our bill. Maybe 18% or 20% would be pretty normal in the United States. If anyone here is from another place where you do tips differently, definitely give us a comment. I'd be super curious to know. I was actually over in another country in France a little while ago, and they didn't even have a way for me to leave a tip at the restaurant. There was no way to leave a tip, which was very unusual to me. But yeah, anyway, that was our tip distribution, and we can keep going with this. We will do some other types of distribution plots. So I want to talk to you about box plot, which is really common in intro statistics courses, and then also the violin plot, which I think I'll be able to convince you that the violin plot is a little bit better than the box plot for most reasons why, for most cases. And we will actually plot them both so that you can just see what I'm talking about. But yeah, Hadrina says we don't do tips as well. Yeah, it's actually less common than tipping, I would say, around the world. But yeah, let's go ahead and try some of these. So when we do our box plot, we use a different Seaborn command. We're going to use sns.boxplot, and we'll type x equals day, y equals total bill, and data equals tips. So data equals tips tells us which data frame to look at, and then X and Y tell us the columns that we want from that data frame. So we could do the box plot by typing tips. We could do tips day like this, but it's a lot easier to just do it this way, where we have X equals day, Y equals total bill. So we're not having to write tips over and over again. So let's see what that looks like. And you can see that the total bill by day is shown for Thursday, Friday, Saturday, and Sunday, which I guess are the only days that we have for our data set. But the total bill does seem to increase a little bit on the weekends. And we can see that by looking at this line through the middle of the box plot. So in that middle line, that would be what we call the median value, just like we had up here for our green dashed lines, these median values. So that green dashed line is the same thing as the straight line through these boxes. So before, remember, that was about 17. But now we're seeing that on some days, like Thursday, for example, the median is actually less. And on days like Sunday, the median is a lot more. So it indicates that more people are spending, or more money is being spent on the Sunday meal. And yeah, why don't we now try our violin plots, and I'll show you a little bit of what I'm talking about with this whole violin thing. And we're going to just do the same exact code, but we're going to use x equals day, y equals total underscore bill, data equals tips. And we'll use that same title, total bill by day. And when we run this code, you can get the violin plots. So the violin plots, I think, are really cool because if you look at the box, you really can't see much about the underlying shape of the distribution. You can see for sure that it has outliers, which are indicated by these markers up in the top, and it has some range. We call this whiskers the interquartile range, which is indicating the 25th and 50th percent and 75th percentile. I'll write that in the chat. But in the violin plot, we can actually see that information, but also see the underlying shape of the distribution. So you can see that there's a really big concentration of data, of bills each day clustered around the normal meals. And then there might be a few that are lower, but most of them are this. And then we could occasionally have a meal which is very expensive. So that would be how the violin plots are nice to look at. And we can now compare the tips amounts by time of day using the same exact formulation. So we're just going to copy this code for box plot of total bill by day. And I'm just going to now put box plot of tips by day. And we will change the Y to tip. And it should now just show us the box plot of tips by day. And that's sort of interesting. Actually, a little bit less of a pattern here, although on Thursday, quite a few bit lower than Friday, Saturday, Sunday. But let's actually now look at the time of day, that by time of day that people left tips. So you can see that in the time of day analysis, where we look at whether the meal was a lunch or a dinner, the dinners were much larger than the lunch, much larger tips. Okay, so here's just some ways to visualize this and begin to understand what is going to matter for tips. Okay, and I want to show you another type of visualization. It's called a pair plot. And so let's just build one. You just use the function sns.pairplot and then give it tips. So tips is just going to then be that data set, that data frame that we had. And let's try it out. So we do sns.pairplot tips. And if we run that code, here's our pair plots. So why I like pair plots is they give you a really good way to just check the basic relationships in your data. So first, we can see on these diagonals, they're showing the histograms of the distribution for each variable of interest. So for example, the total bill histogram looks like this. So you've got a large maximum around a total bill of, let's say, 12, maybe 15. And then you've got a tip, which might be about $3, like we saw. We didn't actually look at the size yet, but the size is indicating the size of the dinner party or the lunch party. So, you could have 2 or 5 people at the dinner table, and but most parties were actually 2 people, which kind of makes sense. But then on these cross diagrams, so let's say we have total bill crossed with tip, you can see that we have a relationship, a really strong relationship between the total bill and the tip amount left. And that's because, as I said before, most people who are dining at a restaurant in the United States would basically just multiply their bill by the tip to get by some fixed number to get the tip. And so that's why there's a really strong relationship. And then in the last column here, we have the size on the x-axis versus the bill and the tip. And you can see there's some relationship there, but it's a little bit weaker between the bill and the size of the party. You get these funny vertical lines because, of course, it's impossible to have a party of 2.5 people to go out to dinner. And then yeah, this is a really good way to just quickly check your relationships within your data. Okay, and let's try another pair plot. We're going to do a pair plot of the IRIS data set. So the IRIS data set is another loadable Seaborn data set, and that's one of the reasons that I really like Seaborn, actually, because they give you these data sets you can practice with that are high quality data. So you just type load data set and then we'll do a pair plot. So, oh, that's actually not right. We need to do sns.pairplot iris. I think show. And so here's our pair plot for the iris data set. You can see all of the different ones plotted out here. Actually, we never even looked at the iris data set, so I'm going to do an iris.head to check it out. And you can see that there are several numbers, sepal length, sepal width, petal length, and petal width. These are all measurements taken from individual plants. And then there's a species on the last column here. So you can see Setosa is one of the species of plant. All right. And of course, Setosa, the species, is not in the pair plot. The pair plot will only work for numbers because a histogram, for example, is only numbers. But you can see there's a really large, a really strong correlation between certain things. So the one that jumps out to me the most is the petal length and the petal width. So the longer the petal is, the wider it is. It's actually probably a really strong relationship compared to most other things. And then another one that jumps out to me is the sepal length with the petal length. So longer sepal is a longer petal, which makes sense. And then also, this is kind of interesting to me, this histogram and this one here, the sepals seem very normally distributed, or at least centrally distributed. So you have just like one central thing, symmetrically distributed, I should say, actually. But then the petals seem a little bit asymmetric. So there are some petals which are really small in this first column here. But then there's another separate larger lengths that are less frequent at the end. So there you go with a little bit of that. And yeah, that's our pair plot. Now, if we want, we can actually pass another keyword argument to the pair plot, and it's called hue. So hue, we can use a categorical variable like species. If we look at the species, I'll just show you the species. You can use .unique to list all the unique species. There's actually 3. There's Setosa, versicolor, and virginica. So if we run this cell now with the hue set to species, you can see that actually we can separate out these relationships by looking separately at species. So now this small blue cluster seems to make a little bit more sense. It's not because these data are just randomly lower, it's because they're actually attributed to a separate species, the Setosa species. So that distribution looks differently. And for example, with these histograms, you can see that each species has a different mean length of the sepal, mean petal length, and things like that. So this is a really great way to check your data out using pair plots. It's kind of a nice feature of Seaborn that you wouldn't necessarily get with Matplotlib. But yeah, why don't we now talk about visualizing relationships, which is another really important concept in data visualization. And Seaborn is a lot easier than some of the native Matplotlib for doing this. So first, I'm going to show a LM plot. So an LM plot is going to basically fit a regression, what we call a linear model. So a model that is saying that this data is like a line. And then we're going to give it 2 variables. The x variable is the independent variable. And then the y variable would be the dependent variable. So that would be the tip. And then the data is going to come from that data frame. So we'll do data equals tips. And then we can add some title. So we'll just say tip versus total bill. So you might remember we suspected that these 2 quantities are very strongly related, and now we'll get to actually see that relationship visualized. So let's go into our data. We'll use our tips stuff again, and we just type LM plot, and we'll add the total bill and the tip as columns, and then we'll put some title and plt.show. So if we run this now, you can see that the linear model was fitted to the data. And there's a little shading here too. You might be wondering, what is this shading about? The shading indicates uncertainty in the slope of this line. So because we only have so much data, it's only a sample of data, it's possible that if we were to see more and more bills come through from this same restaurant, then the slope of that line might change a little bit. And so the shading will help you kind of tell, by how much would it be reasonable to expect the slope to change. So it could be a little bit steeper and a little bit flatter, but yeah, you totally see this positive relationship. And then why don't we do the same thing with the party size and the party tip? So if we do the size of the dinner party and the tip that they left, and we plot this, so we'll do the same title command, but now write tip versus party size. If we run that, we see another positive relationship. And this was a lot harder for us to see, but now that we've applied this linear model, we can see it quite clearly that there is indeed a relationship. And that's a really useful thing. So now I'll show you a little bit about heat maps. So that's another concept that we have. And so heat maps are a way to visualize the correlation between variables. We already looked at pair plots as one way to do this, but heat maps will give you actually a color to represent that. So let's try this out. All we do is take our data frame and type .corr, which is the correlation method. And then we can use a heat map. So let's actually check that out. So we can type car equals tips.car. So, and then actually before we move on to the heat map, I'm just going to run this. Oh, interesting. It seems like we have an error here. So we have apparently some no here in our data set. Let's actually look at that. That looks like the smoker column. So maybe we need to remove some of these categorical things. Let's actually, if we were to just look at total bill, some of these things that are actually numbers, tip, and size, this data set will only have numbers. And I think that's what the error is giving us, because you could see that it's trying to convert these categorical variables like, like, was it breakfast or dinner, into numbers. So if we copy this instead and do the correlation on this, we get a correlation matrix. And so as you might expect in the diagonals, where we're just taking the correlation between the variable and itself, we'll always get a perfect match because, yeah, we're just comparing the variable to itself. But then on these other dimensions, like tip versus total bill, we get a correlation coefficient of 0.67. And that positive number indicates that there's some positive relationship there. And with size, we see it too, but it's a little bit weaker. Once you get to 0, there's really no relationship at all. And honestly, even below that, for most data sets, most small data sets, if you see a R of like 0.4 or 3 or 2, that's pretty much no correlation measured. But yeah, these are definitely meaningful because we have enough data already and a strong enough correlation coefficient to say. There's one here, tip versus size. This is a little bit small. I think, it might be hard to argue that the size of the party and the tip that's left are meaningfully related. But why don't we try now to make a heat map of this correlation so that we can visualize how related some certain things are. So we're going to use sns.heatmap. We just pass in correlation. And I'll also use anote equals true because that will include all of these numbers here too. So if I were to use anote equals false, you see we just get some color map. But I like this annotation. So you can actually see the number and the color. All right, and one of the reasons we use this color bar is because it's perceptually uniform. So even in cases of colorblind readers or someone who is, maybe a little bit could be fooled by a rainbow color map, it will give them a good result. So that's why we would use some perceptually uniform color map. And by default, most of these Seaborn and Matplotlib and things like that already have it built in. Okay, so why don't we do one for Iris too? I'm actually going to let you all try this out. See if you can make a heat map for the Iris data set, knowing what we did for the tips. So I'll give you a couple minutes to try that out. All right, so hopefully you were able to try that out on your own. And now we're going to do it together. So Iris, if we just open up that data set, I'll start by doing just head command to get those first few rows and just investigate. We notice that there's only four variables that have number values, continuous number values. And then there's one species which is actually a categorical value. So we won't be able to use species for our heat map. Why don't we rewrite Iris? So we'll use these double braces like we did before. And we're going to only include those columns which did have numbers related with them. So we did not include species here. And I'm just going to save this to a variable core iris so that we can get it. And then we'll use SNS heat map to basically visualize it. And I'll just add some title too to just show that it would be the correlation matrix of iris features and plt.show. So if we run this now, we get a really nice correlation heat map. And you can see that some of these correlations are even negative. So interestingly, the sepal width, if the sepal width is wide, the petal length seems to be, and the petal width, and they both seem to be kind of smaller, more narrow. And in fact, the sepal width and sepal length are also slightly negatively correlated. But the really key strong correlations that we see are going to be primarily between petal length and petal width, which is 0.96. That's almost a perfect correlation between the two. And between petal length and sepal length. And that's what we observed with our pair plot too, if you remember. So if you're seeing the same thing in multiple lines of evidence, like your pair plot looks really good and the correlation matrix looks really strong, then you can be sure that you're looking at something meaningful. All right, so there is our example with the iris heat map. And now I want you to actually move on to some categorical data visualization. So in this case, we're going to be looking at some categories of data and how we could use Seaborn to do that. And we're going to use some of the same stuff that we used in Matplotlib, but we're actually going to try to expand and look at some other kinds of charts. So the goal is to just expose you to a lot of different types of charts so that we can just pick the right one for the job. And so bar plots is one really good one to check. And we did actually talk about this in Matplotlib, but I just want to show you how it looks for Seaborn. So if we use bar plot, we could do day and total bill. So if we do that one. Oh, hi there, Gluon. Good to see you. I forget, what is a gluon, actually? Maybe you could tell me if you know. I remember learning about that in my science class, I think. But that was a long time ago. So, all right, while we're learning about that, let's go ahead and do our bar plot. So remember, with Seaborn, we can just type the column names as X and Y, which is a little different than Matplotlib. And then write as a keyword argument the data frame. So we do data equals tips. And then we'll add a title, just call it average total bill by day, and then plt.show. And so when we do this, it's showing us the average total bill by day. And this is a little bit different than the bar plots that we saw for Matplotlib, because if you look here, it's actually showing an average for the total bill. And then these black lines are indicating the spread around that. So the spread will tell us, okay, sometimes there was a really high tip on Friday that was almost as high as the highest tips on Saturday and Sunday. But on average, the tip was actually the lowest, or the total bill was actually the lowest. Excuse me, not tips, total bills. So that's kind of an interesting result. And then we have count plots too. So count plot would be you just type count plot, and this only requires one variable. So day and data equals tips. And then we'll just say the count of bills. And if you remember what we did in Matplotlib for our bar charts, this will be a lot more familiar. So here we're just saying, okay, for each of the 4 days, there's a different amount of bills. So actually, it seems like they did the most business, the most bills were delivered on Saturday. And then I guess Friday was the lowest number of bills. But then the bar plots show the average. So it's a little bit different than Matplotlib. Matplotlib would probably look more like this. But anyway, Seaborn is just giving you some additional options on how to visualize some of these things. And we could even show a count of the customers by what time of day they came in. So if we just switch this to, instead of day, we'll just use time. We can do count of bills by time too. So most of the customers are arriving for the dinner shift, not for the lunch shift. That sort of makes sense too. All right, so I want to show you another type of plot that you can make with Seaborn, and that's called a swarm plot. So I think these are pretty cool. And the way that you make them with Seaborn is you type sns.swarmplot, and you're going to need one variable, which will be the categorical variable as your x. In this case, we're using day, but then another variable as your number variable. So that would be your total bill. And so if we type out this code in our editor, we'll do sns.swarmplot, and we'll use x equals day, y equals total bill, and our data equals tips. And so this will give us the total bill by day, similar to bar plot, but you actually get a really good sense of where the data is distributed. So these swarm plots are showing basically stacks of the data, and where you have a case of many bills, they actually spread them out to make it wider. So you can see where the bills are appearing, mostly concentrated in this $10 to $20 range, just like the violin plots showed. But the swarm plot is even more detailed because you can see some of these individual bills here. Okay, so yeah, some kind of particle. We're getting an answer on gluon. It's a subatomic charge entity. That, I have even more questions now. But that's quite cool. So even smaller than an atom. That's very small. Too small for me. But yeah, so we can make another one. But we're going to combine what we learned in pair plots with the swarm plot to include the time of day. So we're going to do a hue for time. And yeah, haha, no Tramish size doesn't matter. Yeah. Actually, yeah, I guess so. I've always found this interesting actually. So the proton is supposed to be the same charge as the electron, but the proton is much larger. That doesn't make any sense to me. Okay, helps bind the protons together. I can get behind that. That makes sense because it's like a glue, right? So that makes sense. All right, so let's edit our our code editor here, we'll go into this swarm plot, and I'm just going to change one simple thing. We're going to say hue equals time. And now if we run this, you can see we have shown the hue. What's really interesting to me is that in the Saturday and Sundays, it's all dinner, and in the Thursday, it's all lunch, more or less. There's one dinner here in the Thursday. Someone, I guess, stayed way too late at the restaurant, and maybe they kicked them out at the end. But yeah, so we wouldn't be able to get this kind of understanding without the hue. And so that can be really useful. Okay, so we can customize our Seaborn plots. I'm going to actually apply some of these things to the Seaborn plot. So why don't we just see what happens when we do this? We did a little bit of this with MPL yesterday, where we actually set some of these styles up. But yeah, let's just say if we put sns.setStyle and we did white grid, what would happen to our plot? So you can see the style of the plot changes a little bit. Honestly, right now, this is giving Excel, don't you think? Like an Excel plot, because it has these horizontal gray lines, and the font even reminds me of like Microsoft Excel. Okay, but we want to not stop there. We want to also check what happens if we do sns.setContext. So we did talk, and it's actually going to control the scale of the elements. So when we do talk and we run, you can see the font sizes have been amplified. And to me, that's really cool because it's helping you make a figure specifically so that people, if you're giving a talk to an audience, people can read the letters. So that's a really useful one too. And now let's do that palette, that color palette. So we do PAL plot, and we can do sns.color palette. We're just applying a color palette to the plot. And it said set to. I'm just going to do one of these, actually. I kind of want to try pastel. I've never done that one. So if we click run, there's our palette. I guess it's actually quite similar. Kind of interesting. Maybe this needs to go at the end. I'm not sure. Oh, yeah, that doesn't work. You need to put it at the beginning. Well, I guess that doesn't really do much for our example. But yes, you could theoretically use the color palettes to change things. Maybe I've done it wrong, actually. Let's try. Copilot seemed to have an idea for us. Set palette might be the right. Yeah, so actually set palette. I should have that there. There's another one we can do, which is actually set style, dark. So dark and pastel. That gives us kind of a nice plot there. So yeah, we just needed to do set palette there, not pal plot. Sorry for that that mistake there. But yeah, why don't we now do a hands-on exercise? And what I want you to do is load a data set of your choice. So we will load a data set of your choice and perform at least 2 different visualizations and then interpret the results. So I'm going to actually show you, I like that Titanic example. I think I'm going to do the Titanic example, but I'm going to show you the load data set possibilities because that's actually really good. Here it is. It's on this person's GitHub. How cool is that, that this person has the Seaborn default data on their GitHub. But yeah, let's scroll through actually some of this. So here's all the possibilities. We can choose anagrams, Anscombe, attention, brain networks. That's interesting. I have no idea how to visualize this. Dow Jones, that's quite cool too. Probably giving you some information about the stocks. But I'm going to go with Titanic. So why don't you all browse these for a few minutes and then I will give my answer here. So just give you a couple minutes to take a look at those. All right, so hopefully you all were able to pick a data set. Yeah, definitely let me know in the chat which one you ended up picking. I'd be super curious to know. But our instructions were to load a data set of your choice, perform at least 2 different visualizations, and then interpret the results. So let's see, I'm going to actually show my, diamond. That's cool. I'm going to load that one. I want to check it out. I never loaded the diamond one before. Let's check it. SNS dot load dataset diamond. Oh, capital D maybe? Didn't work. Oh, diamonds. It's diamonds. Oh, cool. That's awesome. Some diamond gem data set. Okay, nice. Nice choice. I'm going to stick with my Titanic results. A little morbid, honestly, but also kind of interesting just to see the passengers on the boat. So, all right, let's think. So we have to make 2 visualizations. I think I'm going to try to do a bar chart. So I'm first going to just save this load data set. And I want to do a bar plot because I'm really curious how much it cost to stay in each class. So let's actually take a look at that. Okay. So I'll just type Titanic.head just to get a little, I like to have the data in front of me while I'm making these visualizations. But we will do, I think, bar plot. And so we can do x equals, and we'll do our categorical data. So I wanted to put class. And then I wanted to put as the y that number, that fare. And then I'll pass data equals Titanic. So we can see that the first class fare, wow, the first class fare was so much more than the coach. That's almost like airplanes. I mean, airplanes today, I guess the first class is like 10 times, not quite 10 times, but maybe 4 times, just like this. But there actually was some variability there. So there's my first visualization. And then I also want to see if there is any correlation between the age of the person and whether they survived. So we'll do that. I'm going to use LM-plot, actually. And I want to do age. Actually, let's do fare instead, because survived is actually a categorical data. It's just they survived or did not. So I'd rather try this fare. I'm expecting that there's no correlation between these two, actually, but who knows? Certainly today, in today's day and age, you could probably not charge a different fare based on the passenger's age. But let's just see what we get. Okay, so there's basically no correlation, but there is actually a slight positive correlation. And we could interpret that a bunch of different ways. Does anybody have an idea as to how to interpret that slight positive correlation? And then we can actually test. Why would it be that some of these older passengers are getting charged more? Well, I'm going to give a hint here. So if we do hue, we should be able to pass hue. We can do class, and I'm pretty sure that first class, you can see maybe more of these older gentlemen and women are paying for first class. Let's see, actually. Oh, can't do that, but I guess it didn't actually work out that way. Funny. It actually seems like the first class was less for the older people than the younger people. So that's kind of strange, actually. Let's try the age. I'm going to actually do another one. We'll do sns.barplot, and I want to see by class what was the age. Okay. So this sort of confirms more what I was trying to get at. The first class passengers are generally older than the second and third class passengers. So I'll actually delete this one. I don't think this was very helpful. But you could see that the average age was older. So accordingly, the average fare was higher. So when we did an LM plot to see age versus fare, we actually saw a slight positive relationship. So that's kind of an interesting result. And if anybody wants to share their visualizations in the chat, or you want a code snippet in the chat, or you can even paste them into the Discord, We have a great Discord. If you're not joined in, it's https://discord.mlh.io. And I'm going to post mine in the general, not the general chat. Let's post it in the Hack Together chat. All right, so we'll just post our data visualization. I'm actually going to add a little bit of context because I don't want to just randomly post this in the chat. Titanic Fair by class. And we'll put on the y-axis fair in dollars. Let's see, when did the Titanic set sail? Titanic set sail in 1912. So I just wrote 1912 US dollars. And then I'll do an X label, which will be class. Ticket class, let's just say that. Maybe I can just write ticket class at the top and delete this X label. So let's copy this. Two Star says, can you help for a university project? Yeah, if you have some question about Seed Warren or anything like that, for sure. If you want to put a chat, or you can even put it in the Discord. Sometimes some people can help with that in the Discord. Let's see what it would look like, actually. I'm curious because there's an inflation calculator website. So let's check the inflation calculator. Before we move on, I have some other things to show you all, but before we move on, I want to check the FAIR calculator. I want to check the inflation calculator. So here it is. I'm really curious, $1 in 1912, what that would be like today. So let's see here. $1. Let's see, when did the Titanic happen? What month was that? It was April. So we'll just type April. And we go all the way back to 1912. I actually only have data for 1913, so maybe I'll go back to January 1913. Wow, amazing they have data from back then. So, and then we'll do 2024, we have November. Oh, they don't have that yet. How about October? Okay, so September 2024. So that would be $32.17. So if we multiply our data by 32.17, we should get the modern price of a ticket. Let's check that. I'm really curious now. Okay, so we can actually multiply. I'm going to actually say Titanic Fair equals Titanic Fair multiply by 32.17. And this is convert to modern dollars. And let's run this again. And wow, these are our modern prices. I wonder if we can do annotation for this. No, cannot do that. Kind of wanted to see the numbers there. Let's see if Copilot knows how to do that. Sometimes it knows how to do stuff like this. Okay. It's pretty expensive, honestly. Yeah, that's pretty expensive. $439 to go from, I guess it was Ireland. I think that they were going from Ireland to New York. Oh, no, it was from England to New York. So they went from England to New York for $439 at the least, and then it could have been $3,000 at the most. So kind of a cool fact. And yeah, why don't we now keep going here? We'll just do some recap of these, but I actually want to, we have some extra time, so I want to go into some Plotly, which is what we did last time, or which is what I had scheduled for next time. But I actually kind of want to cover some TyPy stuff in part 3. So maybe we'll just get a little bit into Plotly since we have the time. All right, so let's talk about Plotly. We did some static visualizations and communicating relationships between data, things like that. But I actually want to tell you a little bit about Plotly because it's a way you can make interactive plots. And the reason you might want to make an interactive plot is because you can have your audience better engage with the data. So people sometimes like to poke around in the plot and see what's happening. And animations let you have that extra dimension to the data where you can see how things evolve over time or over some span. And those are some of the advantages. So how can you install Plotly, which is what we'll be using for our interactive data visualization? It's actually pretty easy to do. You just type pip install Plotly. And let's actually check in our code scratchpad if we have Plotly. So I might already have it. I'm going to do conda list to check. And you can see we definitely have a lot of stuff. Let's see if we have Plotly. And there it is, Plotly version 5.9. So we're in business. And the way that we import it is actually by typing import plotly.express as px. So plotly.express is just the main library. So we'll just do plotly.express as px. Oh, interesting. It didn't actually work to do that, even though it said we had it. Oh, this is my base. Okay, so actually what I might need to do is activate this environment that I have. And if I do conda list here, we might not have Plotly in this particular environment. Let's see. Yeah, so there's actually not Plotly. So what we'll need to do is type that pip install Plotly here to get it working. Get everything downloaded, dependencies installed. Give it a minute here. And now if we type conda list, we should have it. Yep, there it is. So we have the latest version of Plotly. And if we run it now, we get the right results. So you might need to do that if you don't have Plotly. It's a little bit less common than some of these others like Seaborn and Matplotlib, which tend to come pre-built into some of these applications. But nevertheless, we've got it now. And we're going to try a few interactive plots. So I want to try one to begin with. Okay. And so it's going to be a pre-built one into Plotly Express. So it's actually px.data.stocks, which loads some stock data on Google, Apple, Amazon, Facebook, Netflix, and Microsoft. And what I like about this is kind of cool. You can see how things move over time by using interactive plots. So a lot like you would with some app like Robinhood, for example. So let's take a look. I already have it loaded, px.data.stocks. And to make the interactive plot, all we do is we save this data frame, and then we're going to make a figure that's px.line. And line will give us a line plot, similar to how plt.plot worked from our first part. And then we'll use df to show the data frame. And we have two columns, so x equals date and y equals goog. Let's just do Google, for example. We'll give it some title, and let's run this code. Oh, I forgot the most important part, which is that for Plotly, it's really important to put this .show when you do fig equals here. So that should work. Oh, looks like my environment is not quite working now for that. Might need to try a different environment. Sorry for the error here. I'm going to try my Colab subscription because let's try Google Colab for this one. I don't know if any of you are familiar with Colab, but it's another way to work with notebooks. And I'm just going to open it up in a new screen. So you all can see. So here's the Plotly practice. I think we'll need to connect to a backend here, get a server going to connect. But I'm actually going to paste in that code that I made for last time. So I'm just going to paste in import the import statement. So import plotly.express as px. See if it runs. Hopefully it has Plotly pre-installed. It looks like it does. And then I'm going to paste in my df equals px.data.stocks. And then I'll do my fig equals px.line. Remember, we had Google stock price. And then we'll just do fig.show. So if we run that, this should give us our interactive plot. And what makes it interactive, in a sense, is that you can actually do all this stuff. So you can do a snapshot of the picture. So you can just take a picture of the plot as a PNG. You can zoom. So actually, if we just, oh, that's not the zoom. I think you do. I think there should be a way to do zoom, but oh, you do this, right. So if we double click on zoom to back out, yeah, too much. Oh, there's our data. So we just drag to get the data. So if I want to look at only 2018, but I don't want to remake the plot, just drag along 2018. There's January 2019. And here it is. The Google stock price in 2018 actually went down year to year. So that's kind of interesting. But we can check all this kind of stuff. And we can just drag to see, like, what was it on one particular day, right? So that's kind of a cool thing to do. And let's actually plot it for multiple companies. So we don't need to just do Google. We could also do all the other stocks. So we could do Apple, Amazon, and even Microsoft, I think we had too. And then we can just say stock price instead of Google stock price. And it should work if we run this. Oh, it doesn't seem like it liked that too much. Maybe we need to actually do date 4 times too. I'm not sure. All right, we'll hold off on that one, but you get the idea about the interactive stocks. And I'm also going to create a bubble chart. So this is another thing we can do in Plotly. So I'm going to use a data set called Gapminder, which is another preloaded data set. And you can see we have a lot of information about different countries. So we can see the year of the data that was taken, the country, the population, the GDP, which is a measure of the size of the economy. So we can just check into this stuff by making a bubble chart. So what you'll do is type px.scatter, and we'll type the name of the data set, just like we did before. That's usually the first argument for Plotly. It was the last argument for Seaborn, so that's just one of the differences between these types of things. And then we'll type X. I want to make this GDP per cap for X. And for Y, I'll do life expectancy. So we do expect that there would be some relationship between GDP per capita, which is the amount of money that the country has and how long people can live. And we'll just say size is population. So size would be the size of these bubbles, so they call them a bubble chart. We can encode information in the color, so say continent for color, and we can even add a hover name so that when you hover over, it will tell you that variable, which will be country. And we can add an argument. So I'm just actually going to make this into a multi-line call because it's kind of hard to see. But I wanted to show you this argument, which is log x. And log x is important because it's a logarithm. It will transform the x-axis, this GDP, into logarithm scale. Which is important because some GDPs are very small and some are very large, so we could actually see them all on this log scale better. And so if we run this, we'll have to do fig.show, of course. But if we run this, we should get a nice interactive plot. And here it is. So how cool is that plot? So we can actually hover on these countries to see. As you expect, there's a really strong relationship between life expectancy and GDP per capita. It's actually not 100% explanatory. There are some countries which are having a lower GDP per capita, but actually very high life expectancy, which is quite impressive. And some countries like Japan, which have very, very high life expectancy. But yeah, this is sort of the way you can make bubble charts. And let's make an interactive histogram. So I think this will be the last thing we do today. Maybe we'll do 2 more. So for the interactive histogram, you just basically plot a histogram like we did in Seaborn, but it's going to be in PX. And I'm going to make it for the TIPS data set. So let's do import seaborn as SNS, and we have to make our tips data set like we did in the beginning. And color, day, and bar mode equals, we'll just say overlay. You'll see what that means in a minute. And we'll just give it some title, amount of tip by day. And we'll do fig.show. It can take a little longer because it has to load the data set, but you can see that the tip by day is plotted, so we can actually see like how many tips were between certain values here. Kind of cool. And we should also show you some 3D data. So I'm going to show you how to get the iris data set. We can get the iris data set. It's very famous. We can get it from Seaborn and Plotly. So we actually can just use Plotly directly for the iris data set. And I'm going to use px.scatter, but I'm going to use scatter 3D. Okay. So this will allow us to basically have multiple dimensions for the data set. So we'll say iris as the first argument. And it already suggests what I was going to do anyway, which is plot these three quantitative variables that we had from the data set on the 3D plot. And then we'll do species as the color. And when we run this, oh, I have to do fig.show, of course. But when we run this, we should get a nice 3D plot. Oh, interesting. It actually plotted the... Oh, because I have to do fig here, not iris. Get a nice 3D plot. We can even rotate it and check it out from multiple angles. And it shows us sort of this 3D visualization of what the data set looks like. So it's kind of cool. We're looking at some really neat techniques here. And all right, so that's going to be a bunch of different things that we covered today. Maybe we can even cover one more, which is Choropleth map. This is the population density by country. So, you know, how in your society, how close together do the people live? And so if we look at this, we can use Choropleth map. And so I guess we actually, we don't have the population density. I'm actually going to skip that one for now because I don't have it uploaded. I have the population density chart, but I just don't have it uploaded. So that will have to be it. Let's try this for next time. Okay, I will get that working for us, and yeah. But thank you all for attending today's workshop, and I hope you enjoyed a few of these interactive ideas.